So level 7, we're going to be talking about all about inverse trig functions. So that's the first half, and then the second half is trig identities, and we're going to be doing a lot of proofs. So if you see this layout, the first two sections we're going to divide up and call that a mini test. So on 7.1 and 7.2, sorry that this says level 6, I changed that to level 7. Okay, so we'll have a mini test on inverse sine, cosine, tangent, and all how we use them. And then this second bit for trig identities. So we're going to cover Pythagorean identities, sum and difference formulas, and then double angle formulas, which I have all listed down here. And this is going to fall right, hopefully, before break. And we're going to have a partner quiz or test. So this is kind of give you a brief outline for what we're going to do for level 7. If you flip it over, then we will get started with 7.1. So 7.1, yes, I know that these should say levels instead of chapters. So with level 7.1, we're going to be using a calculator just with trig and inverse trig. So first off, we need our calculators. So I've got my calculator here. So we're just going to start a new document. And I just want to go over a couple features with you guys. Do I want to save? No. Just so how you type these in. So let's add a calculator. The first thing I want you to recognize is if we move this mouse around, we get the mouse up. If you go to the upper right-hand corner, you're going to see that, and you hover over that, it's going to say what your angle measurement is in. So currently I'm in radians, and I want to change that. So if I click on the gear and I go down to settings, and then I go to general, what I want to change is the second thing to degree. So once I change that, I'm going to hit OK. So just as a double check, get my mouse back, we can see that it's in degrees. So see, now it says degrees. Okay, so now we're just going to go type some of these in. We're going to do these columns first. So the cosine, if you hit the button next to 7, it says trig. You guys should be aware of that. The cosine of 25. We hit enter. It says just cosine of 25 because it wants to give us the exact answer. So if you hit control enter, we get our decimal. Okay, so 0.906, 3, then we round down. Okay, the tangent of 21.5. We go to tangent, hit enter, 1 to 1.5. You hit control enter, we get a negative number. That makes sense because that's in the second quadrant. So to the nearest 3 decimals, negative 1.632, because that's 1/8. Cosecant. Now, on a TI Inspire, we do have a cosecant button. But if you don't, so here I could say, what's the cosecant of 21 degrees? I hit enter, and it says 1 over sine of 21. If I hit control enter, I get 2.790. Now, if you don't have one of these, could you type 1 divided by the sine of 21 and hit enter? We get the exact same value because cosecant is the reciprocal of sine. So likewise, the cotangent of 10, here I have the cotangent button, and I can just type in 10, which is the same as 1 over the tangent of 10. Either way, we get 5.671. How about these? Sine squared 40 plus cosine squared 40. So whenever we have these written like this, if we're typing into our calculator, this is going to be the sine of 40 quantity squared plus the cosine of 40 quantity squared. And we have kind of seen this before. It's one of our trig identities that we're going to be studying. But if I type in the sine of 40, and then I say squared plus the cosine of 40 squared, and I hit enter, I see that I get 1 back out. Likewise, the sine of 80 times the cosecant of 80. Well, if I did a little math with this, besides just typing it into the calculator, Cosecant is 1 over sine. So if I multiply the two, I should get 1 out. Okay, so with these other ones that are in radians, so let's get my mouse back. There we go. We're going to go back up to settings. We're going to go here, hit enter again. We're going to go change our degree to a radian. And it's super important, especially if you're switching back and forth physics or math, that we have our angles in degrees or radians. So the sine of pi over 5. We go to trig. There's sine. Now I want to show you that this button right here, sorry, let's make sure that that's on the line we want. Trig, sine. Okay. Now this button right down here next to the h, that's our pi button. We can hit divided by 5, enter. Now that's a really weird number, but if I hit control enter, I get 0.588. 0.588. The cosine of 5. Cosine 5, hit enter. Control enter gives us 0.284. 0.284. If we go to trig and we go to secant, which is 1 over the cosine, I can type this in, 1.4 pi, and I get negative 3.236, and then the cosecant of pi over 12. So this is really just learning how to use your calculator. I'm sure you didn't need me to tell you how to type all of these in, but hopefully this was a little bit helpful in getting the exact values. So 3.864. 3.864. Okay. So this is from level 6, and we didn't really talk about it. So this is just using your calculator. So the big focus on our first part is talking about inverse trig functions. So we use inverse trig functions when we are solving for an angle. And so usually when we're solving for an angle, we are given the sides of a triangle. So the inverse functions undo a given trig functions, if that makes sense. So we write these as inverse sine. So this is read inverse sine. This is inverse cosine, and this is inverse tangent. Sometimes you'll see in the book inverse sine and arc sine, or arc cosine, or arc tangent. All of these mean the exact same thing. And when we talked about inverses in level 5, where you guys were so excited to learn about them, what inverses do is they undo a function. So if we take the inverse sine of an angle, we're just left with the angle. Same thing with cosine. Inverse cosine of cosine is just our angle. Inverse tangent of tangent is just our angle. So with inverses, we usually made a point that the domain is super important. So with the domain, we want to be 1 to 1. If you recall, in order for a function to have an inverse, we need to be 1 to 1. So I will state the domain here, and then we will kind of look at this a little more next time. So the domain of inverse sine is negative pi over 2 to pi over 2. The domain for cosine, inverse cosine, is from 0 to pi, and the domain for inverse tangent is negative pi over 2 to pi over 2. So I'm showing you these right now because we want our angles to fit into these regions. Okay, example 2. Just starting off, find the angle of the given triangle. So I'm going to draw this first triangle out. I'm going to call this theta, and I'm going to say this is 3 and this is 5. So what we can say is we can use our SOHCAHTOA if you forgot. This comes in handy. Opposite hypotenuse. So the sine of our angle is 3/5. So to solve for our angle, theta equals, we would take the inverse sine of both sides. So this would be the inverse sine of 3/5. Now for us, and since we are working with a triangle, we usually want our angle to be in degrees. So let's make sure that our settings are in degrees for any triangle. So setting, let's just change that, degrees. So now I'm going to hit inverse sine. So if I hit the trig button and I go down to inverse and I want 3/5. If I hit enter, I get my angle in degrees, 36.8687. Okay, so this is 36.87 degrees. How did we do this again? We gave a basic trig function, then we undid it using the inverse trig function. So inverse trig, let's just write this in a different color. Inverse trig finds angle measures. Okay, let's flip it over. So with example 3, let's try another triangle. And for us and just getting used to this, we're just going to keep them all in the first quadrant. So let's, given this triangle, let's say this is 5, this is 13. If you don't want to have to do any work, what trig functions should you use? Well, here we have the adjacent side and the hypotenuse. So the easiest trig function we could use is cosine, adjacent over the hypotenuse. So 5/13. So to solve for the angle, we'd say theta equals the inverse cosine, or if we take the inverse cosine of both sides, of 5/13. Now since my calculator is back in radians, I can just do inverse cosine of 5/13, control enter, and I get 67.38 degrees. And then just as a note, when working with triangles, angle measures are in degrees. That's just the general working procedure that we have. So last up, let's say we have a third triangle. Let's say theta's down here again. Let's say we're given this information. So now we've used sine, we've used cosine. So opposite, adjacent, so that's tangent. So tangent of our angle is equal to 4/3. So if we took the inverse tangent of both sides, we would have theta equals the inverse tangent of 4/3. So if I did that, again, hit the trig button, go to inverse tangent, 4/3, and I hit enter, we get 53.13 degrees. So that's using from triangles. So what happens if we're saying find the approximate value of an angle? Well, this is just saying type in our number into our calculator. So inverse sine of 1/3, 19.47 degrees. Inverse sine of -1/4, is -14.14 0.47 degrees. Likewise, we could find these in radians. So it's important that you give your answer in the given units. So in general, what we're going to do is we're going to, for these next ones, we found all of these in degrees. We're going to work in radians. Okay. So inverse sine of 1. What this is saying, what angle is sine theta equal to 1? Well, this is the fun part. Inverse, so one way to think about these questions is theta equals inverse sine of 1. Or better yet, the sine of what angle, of some angle equals 1. Where is sine theta 1? Well, theta has to be pi over 2. So if I go to my calculator, and I do not want to save those, let's add a calculator. There we go. So see that I'm in radians? If I say, what is the inverse sine of 1? Pi over 2. What is the inverse sine of negative 1/2? Or what angle is sine negative 1/2? Well, if I know my unit circle, that should be at negative pi over 6. So if I type that in radians, negative 1/2, I get negative pi over 6. So knowing our unit circle will help. So the inverse sine of pi over 8. Pi over 8 is inside our domain. Remember, I said on the front, the domain of inverse sine is negative pi over 2 to pi over 2. So the inverse sine of this function undoes this and just leaves me with pi over 8. Now, 5 pi over 8 is not between negative pi over 2 and pi over 2. If I drew this out, 5 pi over 8 would be right here. What would be the equivalent in the first quadrant so that we can move this right over here? So all I have to do is move this angle, 5 pi over 8, and find its equivalent in the first quadrant, which turns out to be 3 pi over 8. So that the inverse sine of sine 3 pi over 8 is just 3 pi over 8. Now you might be saying, what just happened? I'm going to type that in for you. Inverse sine of 5 pi divided by 8. You would think that these cancel each other out. They didn't cancel each other out nicely because 5 pi over 8 is not in the first quadrant or in the fourth quadrant. So what we do is we do this little conversion. Now, you might be saying, that's not 3 pi over 8. If I type 3 pi divided by 8 into my calculator, 1.1708. These numbers match. Okay. Next up. Where is inverse cosine, or what angle is cosine negative root 2 over 2? If you're saying 3 pi over 4, you are right. If I go to my calculator and I hit trig, inverse cosine of 3 pi, negative square root 2 over 2, 3 pi over 4. Inverse trig gives you an angle measure. you can also look on your unit circle and say, okay, where is cosine negative root 2 over 2? Second quadrant. There you go. Where is cosine 1? 0. Inverse cosine of pi over 12 is just pi over 12. Inverse cosine of negative 2 pi over 3. If you recall, cosine is even. So if I plug in a negative angle, that's just the same thing as the cosine of 2 pi over 3. Well, these cosines undo each other and just leave you with 2 pi over 3. Last bit, inverse tangent of 1. Where is tangent 1? Or where are the y and x values the same? Pi over 4. Inverse tangent of negative root 3. So we are in the fourth quadrant. And we could say, where is the inverse tangent negative square root 3? So that's where your y values are root 3, and your x values are 1, which should be negative pi over 3. Ta-da, negative pi over 3. So hopefully we get a little practice working with these, and I'll explain a little bit more in class how we are going to go backwards using the unit circle. Okay, hopefully this helped, and good luck working on these problems.